Hello guys, my name is Desmond and I welcome you to my lesson for today. Ladies and gentlemen, I assume at this point in time you know very well that a day without learning something new, it's a day wasted. So guys, by so saying, please do make sure that by the end of each and every lesson that I conduct, you learn something new. Okay, so guys, without any waste of time, in this lesson, I'm mostly interested in speaking about two things. The first thing that I want to talk about, ladies and gentlemen, just write it down so that it forms part of your notes. Okay, so guys, I want to emphasize the equation of the tangent to the circle. This is the first thing that I need you to fully understand. Equation of tangent to the circle. Okay, so ladies and gentlemen, remember, never mind my handwriting, just listen to what I'm saying. If you're writing down your notes, just write what I'm saying. So ladies and gentlemen, I'm saying I want to talk much about equation of a tangent to the circle. Okay, and secondly, I want to talk about the point of intersection of the circle and a straight line. Okay, so I want to talk about point of intersection of of the circle and a straight line. Ladies and gentlemen, please do write down what I've just written down as part of your notes. Okay, so ladies and gentlemen, what I want us to talk about is an equation of a tangent to the circle, and again, point of intersection of the circle and a straight line. Let's firstly talk about equation of tangent to the circle. Okay, as you can see over there, ladies and gentlemen, I've actually tried to draw a circle. Remember, at all times when you try to redraw the given diagram, ladies and gentlemen, or sketch, especially in mathematics, please do start with the axis so that it makes a complete sense. Okay, so let's say we've got our vertical axis, obviously known as the y-axis. We've got our horizontal axis, well known as the x-axis. Okay, so ladies and gentlemen, we can now draw our circle on that Cartesian plane. Okay, so guys, let's now try to draw a tangent. Okay, so a tangent, ladies and gentlemen, what is a tangent? You can also write this as part of your notes. Okay, a tangent, it's perpendicular to the radius of the circle at the point of contact. Let me write that down, ladies and gentlemen. This is a theorem. Okay, you can just write it down to say the theorem states that tangent is perpendicular. Just write it in words, but this symbol refers to perpendicular to the radius, ladies and gentlemen. Perpendicular to the radius, to the radius of the circle, to the circle, let me see, at the point of contact. Hope it makes sense, ladies and gentlemen. So in short, we're saying a tangent is perpendicular to the radius of the circle at the point of contact. Okay, so remember guys, a tangent touches the circle once. I'm not really sure if you understand this part, ladies and gentlemen. Let me just write it down to say tangent touches the circle once, or it cuts the circle at one point. I'm not sure of how to explain this, ladies and gentlemen, but I assume you fully understand. Let me say, for example, ladies and gentlemen, you can have a line going in that direction. Okay, so that means the tangent, ladies and gentlemen, it only touches the circle at one point. Okay, if you have a line going like that, ladies and gentlemen, can you see it cuts the circle at 2 points? This is not a tangent, ladies and gentlemen. We just need that one line that touches the circle once, or at one point, ladies and gentlemen. So this is a tangent. Okay, you just need that line which touches the circle once, ladies and gentlemen, which is at that point. In that case, this is what we call a tangent. Okay, very, very much important, ladies and gentlemen. That's why I'm saying tangent touches the circle once, or at one point. Okay, so over there, ladies and gentlemen, that means this is a tangent and it touches the circle right at that point. Very, very much important, ladies. So that means if you've got a line that cuts the circle through there, so that means it touches the circle there and there. This is not a tangent, ladies and gentlemen. Okay, I hope it now makes sense. So that's what I actually wanted to explain to you guys. So now there's something that I also want to explain. Okay, remember guys, let me just try to redraw that circle and say this is the x-axis, this is the y-axis. Okay, remember guys, the radius can radiate from the center of the circle in any direction. Okay, remember that includes a line along that y-axis or the x-axis, like that. Okay, so ladies and gentlemen, the radius, the length of the radius is the same throughout. Okay, and remember, this is the circumference, ladies and gentlemen. This is what we call the circumference of the circle. This is the radius. Okay, so ladies and gentlemen, what I want to explain, remember we're saying tangent is perpendicular to the radius of the circle at the point of contact. So if we've got a line like that one that touches the circle at just one point, which could be that point over there, assuming that this is that straight line that touches the circle right at that point. Okay, so what we are saying, ladies and gentlemen, is that tangent is perpendicular to the radius of the circle at the point of contact. This is the point of contact, ladies and gentlemen. This is the point of contact. Okay, what point of contact? Is the point of contact of the straight line and the circle. So that means this is the point where our straight line is in contact with the circle, or this is the point where our straight line touches the circle. Okay, so ladies and gentlemen, I'm not sure if that part makes sense, but I assume it does. Ladies and gentlemen, we can still have a straight line, as I've explained previously, in that direction, which means this is the point of contact. Okay, so what are we saying when we say tangent touches the circle once? Obviously, you can see this is straightforward, ladies and gentlemen. So now we say tangent is perpendicular to the radius of the circle at the point of view. So that means, ladies and gentlemen, that radius that radiates from the center to that point of contact, ladies and gentlemen, it forms a right angle in that in that shape, because this is that straight line, ladies and gentlemen. Okay, so we've got that radius that radiates from the center to the point of contact, which is that point. So can you see, ladies and gentlemen, it forms a right angle. That's why we say tangent is perpendicular to the radius of the circle at the point of contact. What about that one, ladies and gentlemen? So that means this is our straight line. Okay, which is that straight line. So we've got a radius which is radiating from the center to the point of intersection, ladies and gentlemen, which is something, a straight line. Remember, it's a straight line from the center to the point of intersection, so it forms a right angle, ladies and gentlemen. That's why we say tangent is perpendicular to the circle of this, to the radius of the circle at the point of contact. What about a straight line in that direction, ladies and gentlemen? So same applies. So we've got that straight line, okay, and then we've got the center somewhere there, and we've got a radius from the center to the point of contact, which is that point, okay? So it also forms a right angle, okay? So ladies and gentlemen, let's say we've got a line that cuts the circle at that point and at that point. Can you see that rule? It doesn't apply, ladies and gentlemen. This is not a tangent because it doesn't touch the circle once. It touches the circle there and there, and we cannot have a radius which is then now radiating from there to there and forming a 90-degree angle. You can see, ladies and gentlemen, it's going to form, there's the center, it's going to form a certain angle, okay? Also the same applies, ladies and gentlemen. It's that straight line is the center, then it's going to form that angle, okay? That's why in situations where you've got a straight line cutting the circle 2 times, that theorem doesn't apply. Ladies and gentlemen, I'm not really sure if you fully understand what I'm trying to say, okay? Just to add to this information that I've explained to you, ladies and gentlemen. So something that you need to know as part of what I wanted to talk about. Remember, I wanted to talk about an equation of tangent to the circle, and again, point of intersection of the circle and a straight line, okay? What you need to know is that the gradient, remember M represents the gradient. So the gradient, ladies and gentlemen, of the tangent, okay, multiplied by the gradient of the radius, ladies and gentlemen, it's equals to -1, okay? This is something that you need to know as part of your notes. So ladies and gentlemen, in terms of giving the notes, this is all that I've got for you in this lesson. Some more will be dished out when we tackle exam related questions, but most importantly, this is all the information that you need to know, okay? So guys, can I just try to explain a little bit more what I mean when I say the gradient of the tangent multiplied by the gradient of the radius, it's equals to -1. So ladies and gentlemen, let's say we've got a circle where the center is at the origin, okay? And again, we've got a tangent. Let me not complicate this with too many lines. This is the graph of G. It could be the graph of H. It could be the graph of F. Okay, so ladies and gentlemen, the question is this a tangent? Yes. Why? Because it touches the circle at one point, or it touches the circle once. Okay, so that means we've got a radius radiating from the center to that point of contact over there, ladies and gentlemen. So can you see we already have that 90-degree angle? Okay, ladies and gentlemen, it's very, very much important that you fully understand that part. This is that graph of G, graph of H, or graph of F. Okay, so ladies and gentlemen, this is the radius. Okay, this is the radius. Okay, so that means this is the tangent, ladies and gentlemen. This is the tangent. Okay, so obviously, because the radius is a straight line from the center to the point of contact, it means it has a gradient. Okay, then let's say this is M of R. Okay, so ladies and gentlemen, obviously a tangent is a straight line, which means it also has a gradient. So let's say a gradient of t. Okay, so that means this is the gradient of the radius, this is the gradient of the tangent. Okay, so this formula, ladies and gentlemen, it says when you multiply the gradient of the radius and the gradient of the tangent, it's equals to -1. Okay, so that's what this formula says, ladies and gentlemen. Same applies. If we've got a straight line in that direction, obviously we know we've got radius radiating from the center to the point of intersection, which forms a 90-degree angle. Okay, so ladies and gentlemen, that means m of r multiplied by m of t will be equal to -1. Okay, same applies if we've got that gradient, ladies and gentlemen. If we've got tangent in that direction, we still have the same thing, ladies and gentlemen. It forms a 90-degree angle. Remember, guys, remember something very much interesting that you need to note. The gradient of that radius from there to there, the gradient of that line, is not the same as the gradient of that line to that line. Okay, it's different because obviously the point of intersection is different. So that means also if we've got a tangent like that, the gradient of that point from that point to that point, it doesn't mean it's the same gradient as from that point to that point. Even though it seems like it's just a straight line, you might find that it's not, but you find that this is a straight line, and then from that point maybe it deviates or it forms a different angle. Then that means the radius won't be the same. Okay, so ladies and gentlemen, in most cases you might find that you're just given one tangent. Okay, so you just work it out using one radius. In this case, I just wanted to explain to you, but one thing for sure, when we tackle exam related questions, that's where you're going to have a complete understanding of what we're talking about. Okay, so do not panic that much. This is all that you need to know. This is all that you need to write as part of your notes. This is what I wanted to discuss, of which I think I did discussed, ladies and gentlemen. I think if we can just try to do one example, then in that way you might have a better understanding, ladies and gentlemen. Let me just erase all of this. I assume you've written down all that you needed to write. Okay, so ladies and gentlemen, I've actually redrawn that sketch over there and explained it. So that one I'll just leave it as it is. So ladies and gentlemen, let's say we've got our Cartesian plane. Let me just draw something a bit smaller. That, and that. Okay, and say we've got a circle like that. Okay, this is the center of our circle, ladies and gentlemen. Let's say obviously this is y, this is x. Okay, so let's say the question says determine the equation of the tangent with center 0, 0. Obviously this is the origin, 0, 0 at the point -3 and 4, -3 and 4, which could be a point somewhere there, -3 and 4. Okay, determine the equation of the tangent with the center 0, 0 at the point -3 and 4. Okay, so ladies and gentlemen, that means we've got a tangent at that point, so you can just draw a line. So you don't need to be given this drawing, ladies and gentlemen. Let me just write down that question. Determine the equation of tangent with center 0, 0 at the point -3 and 4. Okay, so this is all that they give you, ladies and gentlemen, and you need to draw that diagram. Please do understand that part. It's not like you're also given that diagram. Okay, so remember, when we're dealing with circle, you're mostly interested in knowing the point at the center and one point if it's given. Sometimes you're not given that point, you're just given the radius. Okay, so it doesn't really matter that much in terms of what you're given, but it seems like you need just two information, of which it could be the center and just one point, or otherwise the center and the radius. Okay, so we'll see more of that when we deal with exam type of questions. Okay, so ladies and gentlemen, what does the question want us to determine? They want us to determine equation of tangent. So in other ways, they want us to determine an equation of the straight line. Okay, remember, tangent is a straight line. Okay, so that means our tangent, it's going to be something passing in that direction. Okay, this is that point of intersection or point of contact, remember from our notes. Okay, so it obviously means we've got that radius which forms 90-degree angle over there. Okay, so in short, we've got something like that. Otherwise, you can still put it on that side. So this is the center. Remember, guys, m of tangent multiplied by m of radius is equals to -1. Okay, so ladies and gentlemen, obviously for us to determine equation of the tangent, what you need to know is that tangent, ladies and gentlemen, tangent is a straight line. It's a straight line. You remember an equation of a straight line, ladies and gentlemen. I've taught an equation of a straight line from my previous lesson where I've said, y is equals to mx plus c. This c can also be represented as q. Doesn't really matter. Okay, this c or this q is where our straight line cuts the y-axis, and this is the gradient. Okay, x and y is just a point along that straight line. Okay, so because in this case we're dealing with a straight line of the tangent, ladies and gentlemen, we can say the equation is y is equals to m of t x plus c or q. Okay, just so that it makes sense, ladies and gentlemen. So that means now I've just explained that part. Okay, so ladies and gentlemen, mr, it's obvious. I've explained it. I've explained it previously to say m of r is the gradient of the radius. Okay, so that means if we know m of r, we can calculate m of t. If we know m of t, we can calculate m of r. Okay, remember, when I say m of t is the gradient of the tangent, when I say m of r is the gradient of that, you just need to know one in order to calculate the other. Okay, so it depends on the information that we're given. So in this case, we are given 2 points, ladies and gentlemen, that point of contact and the point at the center. Okay, so ladies and gentlemen, I'm just going to teach you how to determine an equation of the tangent based on this given information. So remember guys, this is what we want to give as our final answer, x plus c. Okay, so now ladies and gentlemen, with this information, can we be able to calculate m of r? It seems like we can, ladies and gentlemen, because the gradient of the radius will be equals to y2 minus y1 over x2 minus x1. Remember, we've got 2 points, ladies and gentlemen, 0 and 0 and -3 and 4. Okay, so this is what we're going to do, ladies and gentlemen. We're going to calculate the gradient of that radius. Okay, the gradient of that radius, we're going to substitute it to that formula so that we get the gradient of the tangent. Then we'll be having that portion. Then we use that point to calculate the value of c. As soon as we have the value of c, that means we've got an equation of the tangent. Okay, so that's the procedure that you follow when you determine an equation of the tangent. Okay, from there, as soon as I'm done with this, I'm just going to draw a different circle where I give you a different point and advise you in terms of how to calculate the equation of the tangent for that circle. Okay, so ladies and gentlemen, obviously I've taught you how to calculate or determine the gradient of a particular line. Okay, remember from my previous lesson. So guys, let's substitute. Let's say this is okay, let's take this as our first values, this as our second values. Okay, so obviously 4, let's say it's 4 minus 0, okay, over negative 3 minus 0. Okay, this is obviously equals to 4 over 3. Remember that negative, then it's negative 4 over 3. You can also try to punch this on your calculator, ladies and gentlemen. So that means the gradient of that radius, okay, the gradient of that radius, ladies and gentlemen, m of r is equals to negative 4 over 2. No, 3, ladies and gentlemen. Okay, so let's now substitute it in that formula to say m of t multiplied by m of r, it's equals to negative 4. It's equals to negative 1, ladies and gentlemen. This is the formula. Okay, so now we just substitute this. So that means m of t, then you say into negative 4 over 3, it's equals to negative it's equals to negative 1. Okay, so ladies and gentlemen, you obviously, one can say you cross multiply, otherwise the other one can say, what is it that you do, ladies and gentlemen? You just say negative 1 divided by the whole of that. Okay, so whichever way you deal with this, ladies and gentlemen, it doesn't really matter. I'm not really sure if I've got my calculator. Okay, so ladies and gentlemen, I've got my pink calculator. Let's calculate. So you can say negative 1 divided by negative 4 over 3, and I'm getting m of t as positive 3 over 4. Okay, so ladies and gentlemen, I'm not sure if you're also getting the same answer, but this is what I'm getting, ladies and gentlemen, when I do my calculations. Okay, so guys, that means m of t. Okay, m of t, remember this is the tangent. Okay, so m of t is equals to 3 over 4. Okay, very, very much important, ladies and gentlemen. I assume you fully understand that part. So I'm just going to remove all of this information, but remember, on your page you'll be moving to the next page. Okay, so guys, this is just for you to have an idea of what we're dealing with. Okay, remember guys, in case if you've got additional questions, you can just drop me a WhatsApp text, or otherwise, if you're watching this lesson from my website, www.solvingexampapers.co.za, you can just scroll down on my website. There's a contact form where you can fill in your information, then I'll surely respond to you. Okay, so ladies and gentlemen, remember, y is equals to, what is m of t? It's equals to 3 over 4 multiplied by that x, ladies and gentlemen, plus c. Okay, so now you use that point. Why that point, ladies and gentlemen? Because this is a point along that straight line. Okay, a point along that tangent. Okay, why do you need this point? You need this point to substitute there and there so that you find the value of c. Okay, so let's substitute. Our y is 4, which is that 4. It's equals to, remember this is the gradient that we calculated. Okay, so multiplied by this is that 3, ladies and gentlemen, plus c. Remember, you can either write c, or in some textbooks it could be q. Okay, doesn't really matter. So ladies and gentlemen, what have you got? So it's more like you've got 4, which is equals to that times that. It should be negative 9 over 4 plus c. Okay, then you can just move it to the other side. It means you've got 4 plus 9 over 4. This should be equals to c. So ladies and gentlemen, you just punch it on a calculator. It's going to give you the value of c. Okay, so let's say 4 plus 9 over 4. I'm getting 25 over 4, ladies and gentlemen. So that means the equation of the tangent is y is equals to, remember the gradient of the tangent, it remains, it's 3 over 4x plus 25 over 4. Okay, very, very much important, ladies and gentlemen. So this is exactly what the question wanted you to provide as part of your final answer. Okay, so ladies and gentlemen, this is how you determine an equation of the tangent. Okay, I've just promised you that I'm going to bring a different scenario, ladies and gentlemen. So I'm just going to give it to you as part of your homework. So let's say we've got that, and then we've got a circle. Obviously this is y-axis, this is the x-axis. Okay, so now let me use a point somewhere there where this could be, let's say 5, let's just say that x value there is 4, and let's say that y value there it's 5, and this is the origin, ladies and gentlemen, which is the center. Okay, and they want you to determine an equation of the tangent. Okay, so ladies and gentlemen, obviously you can just draw a straight line passing through that point. Okay, what matters the most is for you to know that m of tangent multiplied by m of radius is equals to -1. Okay, and equation of the tangent is an equation of a straight line. So y it's equals to m of t multiplied by x plus q or c. Okay, so ladies and gentlemen, your first step is to determine the gradient of that radius. Okay, so that is the first step. Let's say step number 1, you determine m of the radius. Okay, that's what you calculate. As soon as you get the gradient of that radius, let's say this is your step 2, ladies and gentlemen. Remember, this is your homework. So your step 2, ladies and gentlemen, will be to calculate m of t. Okay, so obviously you use that formula, ladies and gentlemen. Okay, as soon as you get m of t, then on your step 3, ladies and gentlemen, this is where you calculate the c value. Okay, because you already have that m of t, and again you just use that point of contact, okay, in order for you to calculate that q. Ladies and gentlemen, it's as easy as that. Okay, let me also give you another point as part of your homework. Okay, this is, let's say this is -4, and that y value is 3. Okay, another point again there. Remember, you determine an equation of that tangent, and this tangent again. This is let's say 1 and negative 3. Okay, another point over there where x, let's say x is 3 and that is negative, let's say 3. Okay, remember guys, this is just a hand drawing, it's not drawn to scale. Otherwise, just consider this as multiple circles where you have a circle passing through that point, another circle passing through that point, another circle passing through that point, and I've just explained for a circle passing through that point. Okay, so you need to determine the tangent to those points. So ladies and gentlemen, I assume at this stage you fully understand what I mean by tangent being perpendicular to the radius of the circle at the point of contact. Okay, and again, ladies and gentlemen, determining an equation of the tangent to the circle. So guys, I hope you enjoyed this lesson as much as I did. Thanks very, very much for joining. Ladies and gentlemen, I'm signing out. My name is Desmond, and I'm out.